Problem number 13 here. We're going to go ahead and read the question. Notice it says the graph of a linear function is shown on the coordinate plane. Which function best represents the relationship shown in the graph? So I want you to know, first of all, this is a line, so it's linear. Now there's a couple of different ways that we can solve this problem. One is we can simply find the location of the x-intercept right here, and then get the ordered pair of the y-intercept right here, and we can put it in spreadsheet. And then use menu 461. So that's one way. I'm just going to document that real quick. So I'm going to say one option is going to be that we use spreadsheet. And then menu 4, 6, and 1. But for this, we have to have ordered pairs. So we have to have x and y values. Now the other option that we could use is graphing. Personally, I think graphing is going to be easier, but if some of you like using spreadsheet, you can do that as well. I'm actually going to start by graphing it first to show you that method, and then I'll show you how we could get it using spreadsheet. So let's go ahead and go with graphing. Now with graphing, the first thing I would do is I would look at this graph and remember a couple facts. So one of the facts that I want you to remember is that when we graph something that is linear, it is going to be in the form of y equals mx plus b. And this is important because you need to remember that m represents the slope, or we also call that the rate of change, and b is going to represent the y-intercept. Now I say this because the y-intercept is simply if I were to draw a graph and I had a line on it, the y-intercept is where it crosses the y-axis. For example, right here would be your b value. Inside of the equation, y equals mx plus b. Now that's important because we can look at this graph right here on a computer screen and see that it crosses right here at positive 2. That tells me that in this equation, if I were to rewrite it, what I see right now, even though I don't know what m is, I don't know what the slope is, I do know that my y-intercept is going to be plus 2. The reason I know is because it crosses right here at 2 on the y-axis. Now this is going to be helpful because it's going to allow me to eliminate two answer choices. If I look at my answer choices, and I'm going to go ahead and bring my strike through so we can start striking through things. It can't be A because A has that negative 4 for the y-intercept. In other words, if I look right here, this is a negative 4. So that's wrong because we know that it's a positive 2 for the y-intercept. Also, it can't be C because it has a negative 4 as well. So at this point, the only two options is it either has to be B with a slope of 2, or it has to be D that has a slope of 1/2. Now to figure out that slope, we can go ahead and put it in a calculator and we can look and see which picture matches, and we'll be able to determine it that way. Or we could go ahead and go back and use spreadsheet. But I told you we're going to do graphing first, so let's do that real quick. So I'm going to get my calculator. I'm going to put it right here where you can see it well, and put it so you can see everything on it. Now I'm going to hit enter. Alright, let me go to choose graph. Now here's the graph I want you to go to. This one on the bottom that has a U. I want you to hit enter on it. Notice I already have something graphed, but it automatically opens up a new graphing table. So it says f of 14. That's the same thing as y over here. So what I'm going to do is I'm just going to put what's on the right side of the equal sign. Just like here, I have an equal sign. I'll put all that to the right of it because f of x, or f of 14x, represents y. So I'm going to put in 2x plus 2 because that's the first answer choice we have. I'm going to hit enter. And it looks similar, but to me this graph looks much steeper, right? Going up and down. If you look at this one is not as steep. So that doesn't look like the graph to me. Now, if I wanted to, I could also count the points, right? If I use my little pointer, I can count where the x-intercept is, and to me from origin, it looks like it goes over to the left one time. As where if I'm looking at the graph on the computer screen, it goes over 1, 2, 3, 4. So I don't think this is the graph. So I'm going to go ahead and I'm going to put a strike through. So even though the y-intercept's correct, the x-intercept looks like it's wrong. Now we are going to confirm that this is correct by graphing it. So I'm going to hit on, or my home button, and then I'm going to go hit enter again to go back into graphing. And we're going to graph this second one and see if it looks better. So I'm going to hit Control Divide to get my fraction bar. I'm going to put 1 over 2. And then I'm going to put x. And according to here it says plus 2. That's my y-intercept. Hit enter. And then I'm going to check this one. Now this one, notice it's not as steep, right? It looks very similar to what I have in my screen. So I'm just going to check and see does it cross at the same place. On my computer screen, I notice my x-intercept is right here on the x-axis, and it's -4. It crosses at -4. And if I get my pointer here, you can actually see if I go over, it goes over at 1, 2, 3, and 4. So it actually crosses at -4. Another way, if you wanted to find that, is you could go to Analyze Graph and put find 0. Remember we talked about zeros in class earlier in the year. A 0 is the x-intercept. So I can come across, hit OK, drag it, hit OK, and it gives me the point of my 0. My 0 is -4, 0. And that's exactly what we have here is -4, 0. Then I can check my y-intercept, right? Here's this +2. And of course, we put the equation in. We know that the y-intercept is +2 because of what our equation says. But we can also just look at it with our mouse, right? You can go to origin right there and see that we go up 1 unit and then we go up 2 units to get to it. So this graph matches perfectly, and so therefore I am confident that D is the correct answer. I think that's the best way to find it is just by looking at the y-intercept and then typing it into your calculator and matching the picture. Now let's say for some of you, I'm going to continue with this, right? Let's say some of you don't like doing it that way. You go, Mr. H, I don't like graphing. Can I find it another way? And the answer is yes, we can use our spreadsheet. The first thing that I'll tell you is we do have a y-intercept of -4, 0. So remember the x value always goes first. We do our x value first, and then we do our y value second when we're looking at ordered pairs. X value first, y value second. And I'm going to look at my x value right here. For the furthest left intercept, which is the x-intercept, right, it's -4. And then for the y value, it is 0. Because even though it lines up, it crosses at -4 on the x-axis, that lines up with 0 on the y. And then I'm going to put my y-intercept. Now my y-intercept is at 0 on the x-axis, so I'm going to put a 0 right there. And if I go from 0 on the x-axis up until I touch the line, it crosses at +2 on the y-axis. So that's +2. Now I'm going to get my calculator, and I'm going to actually use spreadsheet using the x-intercept and the y-intercept to go ahead and see if I get the same answer. So I'm going to go into spreadsheet. Now notice I do have a lot of spreadsheets, so I'm going to delete it out. Go back in, change A to X, change B to Y, and I'm going to put in my ordered pairs, -4 and 0. That's my x-intercept, and 0 and 2. That's my y-intercept. Now once I put all those points in and I click out of that last box, I'm going to go home. I'm going to go to data, the one right beside it, hit enter. I'll go down to the bottom and change this axis to X. I'm going to change this one to Y, and then hit menu 4, which is analyze, 6 for regression, and 1 for show linear mx plus b, because this is a linear equation. And notice it gives me the equation y is equal to 0.5 x plus 2. So if you decided to do it this way, you would have been able to eliminate A and D just by looking at this and going, you know what, I have a y-intercept of +2, and then you would have had to figure out which one of those slopes was correct. And this one says 0.5, and just remember 0.5 is another way of writing 1/2. So we know that for facts, D is the correct answer. It doesn't matter if you used graphing to find it or if you used the spreadsheet menu to find it. You would get the same answer. Pause this video, try to solve 14 on your own, and then hit play on it and see if you get the same answer that I got. On number 14, notice it says which statement about f of x is equal to 12x squared minus 36x plus 27 is true. So we have 4 different statements. I would always say read the statements first and then go ahead and go back and try to see if you can figure it out. But notice this says the zeros are positive and negative 2 over 3 because f of x is equal to 3 times 2x minus 3 times 2x plus 3. So notice that they're just giving us a quadratic that's in a different form than what we normally have here. This is our standard form, and they're giving us this right here in a different form, right? It's written as 2 binomials being multiplied with a greatest common factor in front. Now what I would do is, before I do anything else, I would want to graph this to actually see, are my zeros actually 2 over 3? Or if you look at the next answer, it says they're 3 over 2. Or is it 3 over 2? And then if I go down further, notice it says the only zero is 2 over 3. And this one says the only zero is 3 over 2. Now, because they're telling me that in these two cases, in C and D, there's just one zero, when it says only zero, and it doesn't have the plus minus in front, it just means that there's one positive zero. And this one up here on top, these two, is telling me that there's 2 zeros. So by graphing this, I'll be easily able to see if there's 1 0, 2 zeros, and I can either eliminate A and B or eliminate C and D. So I'm going to write this down. I'm going to say in one like this, if you get one like this, I think that graphing is the easiest way to determine which answer is correct. So we're going to do graphing. So let's go ahead and do that. And right before we do that graphing, I'm also going to check the zero. Since we notice they're telling us that it's either 2 over 3 or 3 over 2, I don't know what the decimal value of that is. And whenever we use the graphing feature, it'll give us the zero, but it's always going to give it in a decimal. So I'm going to go ahead and put these in a calculator with a decimal after them and convert them to a decimal so that we know exactly what number we should be looking for our zero. So let me do that before we even go to graphing. I'm going to get my calculator. I'm going to go ahead and go home. And I'm going to go up to calculate, the one that says A calculate. That's my favorite one to use. And I'm going to put in this first fraction. So I'm going to hit Control Divide, and I'll do 3 over 2, put a decimal, and that gives me 1.5. So I'm going to write that real quick. So this one should have a 0 of 1.5 if it's 3 over 2. And then we have 2 over 3. So Control Divide, 2 over 3. And that's going to give me 0.6 repeating. So that's going to be my second option. So I'm going to write 0.6 repeating. And that just means the 6 goes on forever. So now let's go ahead and graph it. And when I say graph it, I mean graph this original one right here. We want to graph this original one, this 12x squared minus 36x plus 27. And then we'll worry about figuring out which one of these was written in its expanded form correctly. So let me go ahead and put my calculator up here. Now to graph it, I want to go home. And then I'm going to go down to graph, down here at the bottom where it says add graphs. It brings up my f of x tab, and I'm going to type it in. So I have 12x to the power of 2. And then I have minus 36x minus 36x plus 27. Now notice it matches exactly what the test says. I'm going to hit enter, and there's my parabola. Now just looking at it right here, it looks like to me it only has 1 0. I don't see where it crosses twice. This one over here, A, says that it has a 0 on the left side too, which means a 0 over here on the negative side. Anytime you see a plus and minus right there, and they got it where it kind of looks like it touches, I feel like theirs looks a little confusing. But just so you know, when that symbol they have that looks like this, right here, it's actually a plus sign and a negative sign. And what that means is, what they're trying to say is that you have a parabola that looks like this. It has a 0 on the left side. It has a 0 on the right side. Now on the other hand, if we look at C and D, it says the only 0 is 2 over 3. are the only zeros 3 over 2. What they're saying in that one is that you have a parabola that only has one zero and it's positive. In other words, the graph would look like this and just have 1 0. Now this is important, right? I'm going to write beneath it. This is 1 0. This one has 2 zeros. Now if I look at my graph, to me my graph, it looks like this 1 0 situation where we have just one positive 0. So I'm going to go ahead and strike out A and B. I'm not even going to check those because they can't be correct, because they're saying that it has 2 zeros and the graph, the original graph that I just graphed, only has 1 0 on the right side, which is positive. So let's go and start striking through. So we've narrowed it down now. It's either going to be C or it's going to be D. So what I want to do is I'm going to go ahead and graph it. And you can graph it in this expanded form. Notice, right, I have 3 and then I have 2x minus 3 squared. I can put that in the calculator. It'll graph it. So what I'm going to do is when I do the first one, I'm going to hold tab and let me type it in. So I'm going to put a 3 because that's what they got after the f of x and the equal sign. Parenthesis 2x minus 3 close parenthesis and squared. Now before I hit enter, what I want to tell you is if we were to look at this graph, if this is the correct graph, it's going to actually highlight this graph because they're going to be sitting on top of each other. If it gives me a different graph that's over on the other side, or it's further to the right or further to the left, then I know it's not correct. So I'm going to hit enter. Do you see how it highlighted it? And now my graph looks like it's two different colors. I'm going to zoom in real quick just so you can see. I'm going to zoom in. Plus I'll zoom in on the 0 so that we can actually check the 0 and see what the value is. But notice my two graphs are exactly identical. They are lying on top of each other. I'm going to go ahead and check the 0 now. So this, to me, I believe this is the correct answer. So I'm going to go to Analyze Graph, find 0, hit enter. I'm going to go ahead and didn't take for some reason. So let's try it again. Actually, let me go ahead and zoom out. Escape. I'm going to go back in. I'm going to regraph it real quick because I just want to check that 0. The graph looked right to me, but I do want to check the 0 and confirm that it is a positive 2 over 3. In other words, 0.6 repeating. So I'm going to put the original one in. The original one was 12x squared. And then we had minus 36x plus 27. I'm going to hit enter. Okay, so I'm going to find that 0 right there. I'm going to hit menu. I'm going to go down to Analyze Graph and find 0. Alright, now it's got this dotted line. Probably won't let me do it because we have two graphs in there. So I'm going to drag it across and hit enter. And I want you to notice that this says my 0 is 1.5. So even though I thought this was going to be the correct answer because the graph looked like it lied right on top of it, I want you to notice my 0 says 1.5. And if you notice, if it was that first one, C says that it has a 0 of 2 over 3, which is 0.6. So this is a pretty tricky question. We could have got this wrong had I not checked to see what the 0 was in the calculator. So this 2 over 3, it's not right. I'm going to strike it out because that 0 would have showed 0.6. So since we had 1.5, it has to be D where it says the 0 is 3 over 2. So I'm going to graph that one and see if it looks like it lies on top of it as well. So I'm going to hit tab. That'll let me graph a second graph. And I'm going to put in 3 parenthesis 2x minus 3 close parenthesis, and then I'm going to square it. Notice it does lie on top of it, and it does have that same 0 as 1.5. I want you to also notice this when I go back to it real quick. I want you to notice that they gave us the same equation. Do you see that? F of x is equal to 3 times 2x minus 3 squared. 3 times 2x minus 3 squared. And that's why my graphs look the same. So if all you did was check the graph, you might think that C is the correct answer. But we had to go back and look and see, was our 0 2 over 3 or was it 3 over 2? And in this case, it was 1.5, which means it was 3 over 2. So really tricky question. That is wrong. The only correct answer is D. Go ahead and pause this video now. Try to do the next problem on your own, and then watch my video to see if you got it right. On problem number 15, it says the graph of a linear function is shown. What are the slope? So I'm gonna go ahead and let me go up here and grab one of my tools. I'm gonna highlight this section because I'm looking for the slope, and they want me to find the y-intercept. So I'm gonna highlight it. That best represents this linear function. Move the correct answers to each box. Each answer may be used more than once. Not all answers will be used. So we're really just going to pick two of these, right? So one represents the slope, my m, and one represents the y-intercept. Once again, when you see a problem like this, what I want you to really think about and remember is that in the equation, y is equal to mx plus b. Remember that m is the slope, and sometimes it is also called the rate of change. And b is the y-intercept. Now, in order to find both of these, we are going to need to find two sets of ordered pairs. You could count rise over run if you wanted to, but I think it's easier to just go ahead and get two ordered pairs. And so what I'm going to do is that's going to be my first approach, and then I'll show you how to do it by counting rise over run and looking at the y-intercept. So I'm going to go ahead and write two ordered pairs. So, and I'm also going to write my technique. So we have the spreadsheet technique, where we use menu 461 because it's linear. The other technique is to find b, the y-intercept, and count rise over run for the slope. So we have a couple different ways. This is more like a 7th grade way of doing it, where we count rise over run. And a spreadsheet, right, that's what you would have learned typically in 8th grade, or how I would have taught you this year, because it's really easy to do. Now your third option is use the slope formula, but I'm going to focus on spreadsheet and counting rise over run. So first of all, let's get our two ordered pairs, because if we do this, we got to have two ordered pairs. And you want to remember that when you write your ordered pair, that the x value is always the first number, and the y value is the second number. The other thing is, when I talk about y value, I'm talking about the y-axis that runs up and down. And when I say the x value, I'm talking about the x-axis that runs left and right. So the number off the left and right bar, right, the horizontal one, goes in front. The number off the vertical one, which is what we call our y-axis, goes second. So I'm going to start with this line. I'm going to go furthest to the left and find my y-intercept. And it looks like to me it's right here at -4 on the y-axis. And that lines up with 0 on the x-axis. So if I wanted to write that, I would actually say the x value is 0. And the y value, or my y-intercept value, is -4. So that's this first point where my arrow is right here. That's 0, -4. Another good point, if I follow it, looks like to me I have a x-intercept right here where it crosses at 2 and 0. My x value is 2, and that lines up with 0 on the y value. So I'm going to write that. So I have 2 for my x value, and I have 0 for my y value. Now, once I've put this in spreadsheet, right, it's going to make really easy work of it. I'm going to have an equation, and it's going to say y is equal to some number representing the slope. And then we're going to have an x, and then we're going to have plus or minus whatever the y-intercept is. So we're going to write that answer right in here. And let me go ahead and put it in spreadsheet. So I'm going to get my calculator right here so you can see everything. I'm going to go ahead and go home because I want to go to spreadsheet. So let me go over to spreadsheet right here in the middle where it says spreadsheet. Hit enter. Now I'm going to delete it because I did one earlier. So we have some spreadsheets open. No, we don't want to save it. Hit enter to go back in. I'm going to change A to X. I'm going to change B to Y. And I'm going to put in my ordered pairs. Okay, now that I've done that, I'm going to go ahead and type in my next value. So I'm going to put in 2 and 0. Click out of that last entry, go home, go to data and statistics and hit enter. I do want to go down here to the bottom and click and change that axis to X. On the left, my vertical axis, I'm going to change it to Y. And then do menu, 4 for regression, 6, or 4 for analyze, 6 for regression, and 1 for show linear mx plus b. Now notice this gives me y equals 2x plus minus 4. So I'm going to fill those numbers in. My slope is 2, and my y-intercept is negative 4. The negative always wins. So if it says plus negative, it's just minus 4. So we have our answer. So when I go over here, I'm just going to drag these boxes. I'm going to take that positive 2 for my slope and put it in the slope box. And I'm going to take that negative 4 for my y-intercept and put that where it says y-intercept. Now I told you there's another way we could have done it. So for those of you who are looking at it going, Mr. H, I'm not good at finding ordered pairs, or I think during stress I may just forget how to use spreadsheet. Well, we can just simply find the b value, our y-intercept, and then we can go and count rise over run. So let me show you how we do that. So for instance, I'm just going to write b equals, we're going to find our b value, my y-intercept, and if I just followed my y-axis down into where my graph crosses, notice it crosses at negative 4. So in this case, b is equal to negative 4. And then to find my m, my slope, I'm looking at my rise over run. And when I say rise over run, I'm going to look at the up and down movement over the run, which is my left and right movement, from one point to another on the graph. So I'm going to give you an example here. Let me go ahead and I'm going to use my draw feature. Now I'm going to line this up just so it matches, so you can kind of see that it matches up right here. And they don't match up perfectly, but I'm just going to use this to draw on. So let me click on draw. So I'm going to put a point right here at 4. And then what I'm going to do is I'm going to go ahead and I'm going to count the spaces that I go up. So I went up to 1, that's 3, right? And then I go up again, that's 2. And then notice that there's a point right here. But if I didn't realize that, I could actually go up because this grid doesn't match up perfectly. I can put a point right there, a dot right on 2, 0, which is my x-intercept, and I could just keep going. So go up 3 and go up 4 times. So in this case, I went up 4 units. So my rise is 4 units. And then from there, I'm going to go over, I'm going to change it to a different color. From origin, I'm going to go over 1, 2. So I went to the right 2 units. Now if I take that 4 over 2 and I put that in my calculator, go up to calculate real quick, and I did 4 over 2 and I hit enter, it tells me that it's 2. So then I could say, well, the slope is equal to 2. And once you got your m value, you have your slope of 2, and you have your b value, which is negative 4, you could have just wrote the equation y equals 2 x minus 4. Because remember, this is my m right here, and this is my b right here. And you still would have got the same answer, right? You would have put 2 for the slope, -4 for the y-intercept. This is another way that you can do it, or you can use spreadsheet. So that's two different ways that you can find the answer. You can use the graphing tool to help if you like that, if that seems to benefit you. But now what I want you to do is pause this video, try to solve number 16 on your own, and then come back and recheck it on number 16 to see if you got the same answer that I got. Now that you've done problem number 16, watch this video. Let's see if you got it right. So first of all, notice this says which expression is equivalent to z plus 5 times z squared minus 4z plus 6. So this is where we kind of have to do a modified FOIL because there's 3 terms in this second one. This is a trinomial and the first one's a binomial. And so we're going to use a modified FOIL method. So I'm just going to refresh your memory about FOIL. So when we did FOIL in the classroom, remember this was first, outer, inner, and last. So I'm going to go ahead and write this and set it up real quick. So I'm going to have a parenthesis, and then we have z plus 5, close parenthesis, and then we have another parenthesis, and we're going to do z squared minus 4z plus 6. Now the way that we should solve this right here is we're going to go ahead and we're going to distribute each one of these terms. So just like a FOIL, I'm going to start with the first term. So the first term is this z, and I want to multiply it to what is inside of the parentheses here, which is z to the second power. So we have z times z to the second power. Now if I were to multiply that out, remember that we have a power rule that says anytime you multiply a variable to the same base, you just add the powers. And you might forget, but the power on this z that doesn't have one is actually a power of 1. So this is like saying the power of 1 plus the power of 2. So z times z to the power of 2 is going to give me z to the power of 3. Then I'm going to take that z and I'm going to multiply it to the next term, which is -4z. So z times -4z. And if I multiply that out, I have a z times another z. So there's 2 z's, so that's going to make this z to the power of 2. And then the -4, we just put that in front. So -4. And the reason I say that is because really there's an invisible 1 in front of this z. And 1 times -4 is just -4. Now we got to take this z and we're going to multiply it to the last term, which is 6. So z times +6. And that's just going to become plus 6z. Now we do have to deal with the next term. The next term is going to be our 5. So this is going to be our inner. And we're going to take that inner and multiply it to the z squared. So 5 times z squared, which is going to give me plus 5z squared. And then we have plus 5 times -4z. So 5 times -4z, which is going to give me, if now this one, right, we want to start using our calculator, we start dealing with 2 digits. I got a 5 multiplied to a -4. So always use your calculator. Never guess, never do what you think. Use the calculator, see where you're at. 5 times -4, and it gives me a -20. So I'm going to write this as -20z. And the last one is we have to take this 5 and multiply it to the +6. So 5 times 6. If I get my calculator, I do 5 times 6. It gives me 30. So that's a +30. Now we're almost done, but at this point we just have to add like terms. So we're going to put everything that's alike together. Now notice I only have one z to the power of 3. None of these others have a power of 3. So that's going to be my leading term. Remember when we talked about leading terms, we said it's the term with the highest power. So we have z to the power of 3. Now what I want to do is see if can I find anything that has the same power and the same variable. So for instance, right here I have negative 4z to the second power. I'm going to box it. I also have one that's a positive 5z to the second power. Now these are the same. I'm going to put them together. I'm going to put this one right here and this one right here together, and then I'm going to write the answer down there. So this one is z squared, this one is z squared, but here I have a coefficient of negative 4, and here I have a coefficient of 5. So I'm going to put that in my calculator. Negative 4 for the first one, right, because we have a negative 4. And then I'm going to put plus 5z for the next one, plus 5. So I'm just taking the coefficient of the first and adding the coefficient of the second. And it gives me a positive 1. So you don't have to write 1z. You could, but on the STAAR test, they're not going to have a 1 in front of it. So I'm just going to write 1, so plus 1 z squared. I left the 1 off because it's not required. Anytime you see a z, there's always a 1 in front of it. Now let's look at the next two terms we could put together. I recognize that right here I'm going to circle it, I have a positive 6z, and right here I have a negative 20z. So we're going to put those together. So I'm going to bring this and this, put it together, and write the answer right after, which is the next lowest power. And so I have a positive 6 for the coefficient and a negative 20. So I'm going to put those two numbers together. So positive 6 and negative 20, so minus 20. And that leaves me with negative 14. So for this one we have negative 14 z's. The only thing I have left is this 30 over here, and there's nothing to combine it with, right? It's all by itself. So I'm just going to take it and write it down at the very end. Always put the constant at the end. Plus 30. And there's my answer. So it looks like the only one that matches, let's see, this is z to the third, but this says 5z to the second. So that's not it. I'm going to go ahead and strike it out. This next one says z squared plus z, but it doesn't have a z to the third power. So it can't be that one. Can't be this one because they don't have z to the third power. And the only one left that matches is z to the third power plus z to the second minus 14z plus 30. So C is the correct answer. So it's a lot of work, right? We did this modified FOIL, but that's how you would get the answer to this problem. Go ahead and pause the video. Try number 17 on your own before resuming. On problem number 17, it says the graph of a quadratic function is shown on the grid. Which statement is best supported by the graph? So let's go down and look at our statements real quick. This one says the function has a 0 at 6. Okay, so what we do is you got to remember what is a 0. And so I'm just going to draw you a picture real quick. If we were to draw a graph, and you know what, let's draw one that looks similar to this real quick. Actually, you know what, I'm going to draw one just freehand. It's not going to look exactly the same, but it's going to look similar. Alright, so zeros are where we cross the x-axis. Now, not only are they called zeros, I just want to make sure you remember, not only is this called a 0, it's also called a root, and it's also called a solution, and it's also called a x-intercept. So this is a 0, a root, a solution, or an x-intercept, where it crosses the x-axis. And if you notice on this one, we have a 0 at negative 6, and we have a 0 at 0, at origin. So in other words, there is currently one on the graph that we have. Our zeros are going to be at negative 6 and 0, and 0, 0. So on this one where it says the function has a 0 at 6, well, no it don't, right? It's a negative 6 that has a 0, and it's a 0 it has a 0, but it does not have one at positive 6. So we can strike that out. The next one, B, says the minimum value of the function is 9. Okay, so remember that whenever we did our transformations on quadratics, what you would have seen is when we have a parabola, and actually I should draw it like this. When we have a parabola flips down, it has a maximum. This point right here, our vertex, is the maximum. In order to have a minimum, we have to have a parabola that flips upward, like this. Then the vertex would be the minimum. So this one right here, it doesn't have a minimum. It has a maximum. So when it says the minimum value is 9, that's wrong. That's a maximum value. Next is the vertex is 9, 3. Okay, well, the maximum is also known as the vertex. Just like a minimum is also known as the vertex, because that is the point that is going to be the highest or lowest on any parabola depending on which way it's flipped. So this one says the vertex is at 9, negative 3. Okay, if I go to the vertex, which is my maximum point right here, it does line up with negative 3 on the x-axis, and it lines up with 9 on the y-axis. But what you got to remember is when we're writing, I'm going to write it down here. I'm going to write the vertex of this, vertex of our graph. In this case, we always put the x value first. So first I would put the negative 3, and then I will put my y value, that's 9. So notice they were pretty tricky on here because they gave us a 9 and a 3, right, for our answer, but they switched the numbers. They actually gave us the y value first and the x value second, which is wrong. So it can't be that one. We can strike it out. So the only one left is going to be D. And D says the equation of the axis of symmetry of the graph is x is equal to negative 3. And that's true. And that's because, once again, I'm going to go back to when we were doing the transformations of quadratics. Whenever you had a parabola, and let's say I'm going to just draw one on this side right here. And let's say that this value is 1 and this is 2. So that's 1, that's 2. What you got to remember is when we talk about the axis of symmetry, it's the point at which it cuts the parabola in half to make a mirror image. That's the axis of symmetry. And I'm going to write there, axis of symmetry. And what you got to remember about the axis of symmetry is it is always in relation to an x value. In this case right here, because I have it on 1 from an x value, it would be x equals 1. In this case, on the graph that we have here on the test, notice it lines up with the x-axis on 3. That would be my axis of symmetry. And let's see, I'm going to turn down the transparency on my grid. I'm just going to put this up here, right? If I wanted to actually draw a line, because notice you can go ahead and you can draw if you want to, put a point. And let's say I put a point here, and I'm going to connect the line. That is my axis of symmetry right there, where it cuts it in half, and it lines up with negative 3. So x equals negative 3 is true, and that is the correct answer.